Hello students of 11th class. I am Pardeep Koul, lecturer in chemistry, and today we will continue with thermodynamics, and today's topic for you is thermochemical reactions. Now in thermochemical reactions, the word Therm means heat and chemical reactions means chemical reactions. So, what are now thermochemical reactions? Coming to this term, that is this, thermo stands for heat. Now, what happens to heat in thermochemical reactions? Suppose this is a reactant. It undergoes a chemical reaction, and suppose it forms products. Now, when this reaction takes place, there is change in enthalpy or change in heat. That change in heat can be positive as well as negative. That means this reaction may take place accompanied by addition of energy. By addition means absorption of energy, or vice versa, that means evolution of energy. So all chemical reactions are accompanied by change in heat. That means when a reaction takes place, when reactants change into products, there is change in heat. Either the heat amount increases or it decreases. That is, either the heat transfers from the reactant to the products or from product to the reactant. In other words, we can say that heat may shift, it may transfer from the system to the surroundings, or vice versa. That is, from heat may transfer from surroundings to the system. These are the two cases. Now, so what are now thermochemical reactions? If we go to the definition of thermochemical reactions are those chemical reactions which are accompanied means they take place, and while they take place, something accompanies the reaction. What accompanies the reaction? Which are accompanied by the change in therm. Therm means heat content. Change in heat or enthalpy. Enthalpy, you know, it is denoted by H. So such chemical reactions are known as thermochemical reactions. Now, as I just told you, that when a reaction takes place, either there is evolution of heat, that is, heat is given out during the reaction, evolution of heat, or it can be vice versa, that is, it can be absorption of heat. These are the two cases which can take place during the course of a chemical reaction. Now, depending upon this, whether there is evolution of heat during a chemical reaction or there is absorption of heat during a chemical reaction, depending upon these two, our thermochemical reactions can be classified into two types on the basis of whether there is evolution of heat or there is absorption of heat. So on this basis, thermochemical reactions can be classified into two types. So these are thermochemical reactions. These can be classified into two types. One type is exothermic reaction, and another is endothermic. So what are exothermic and endothermic reactions? These are the two classes, two types of thermochemical reactions. Now let me first come to exothermic reactions. What are exothermic? Exo stands for evolution. So exothermic reactions are basically thermochemical reactions. The thermochemical reactions that are accompanied by evolution of heat. By evolution means heat is evolved, heat is produced, heat is released from the system to the surroundings. Evolution of heat are called thermochemical reactions. Now in these reactions heat is evolved. Now if heat is evolved, it is evolved from the system. So system gives out the heat and it gives out the heat to the surroundings. So in exothermic reactions, what happens to the heat? Heat is transferred from the system to the surroundings. Now, what happens to heat? I just told you that heat transfers from system to the surrounding. For example, this is a typical example of this N2. But before going to example, let me clear one more thing. In these reactions, the heat of this, that is heat of the product, this is product, these are reactants. Heat of products, heat also means enthalpy. Enthalpy of products is always greater than enthalpy of reactants. Please remember, in exothermic reactions, enthalpy of products is greater than that of reactants. That means if we want to determine change in enthalpy, that is delta H, the formula for determining delta H is HP minus HR. It should always be negative. So remember that in these reactions, that is in these reactions, the heat of this, that is heat of reactants, it is always lesser than that of products. Now coming to certain examples, say this is nitrogen plus hydrogen, both gases, they together form ammonia. Now in this reaction, see how much heat has been given out, 93.2 kilojoules. That means this much amount has been produced. That is, it has come from the system to the surroundings. So heat evolved has been given which sign? Heat evolved has been given positive sign. This is a positive sign. So always remember that heat evolved during exothermic reaction is always given which sign? Plus sign. But if we want to determine delta H, that is change in enthalpy, that is always negative. Why that is always negative? Because heat of products, as I just told you, is greater than heat of reactants. I can rewrite this reaction if I wish to rewrite this reaction in terms of this is not delta H. This is not delta H. This much energy has been released. It has come out from the system to the surrounding. But if we want to determine delta H in this case, delta H will not be positive, it will be negative, because this much amount of heat has been evolved, it has gone out, and therefore it will get which sign? It will get negative sign. It will be 93.2 joules. Now, heat of products is always less than that of reactants. Only then delta H can be negative. Please remember that heat of products should be less than that of reactants. Only then delta H will be negative. So the sign given to heat evolved is positive, but delta H is always negative. We can rewrite this reaction in terms of delta H like this. Nitrogen plus hydrogen gives twice ammonia. Now I will write this reaction in terms of delta H. Now delta H means change in heat. That is negative. Now this sign will not be positive. This will be minus 93.2 kilojoules. So this is another way of writing this reaction. If we write in terms of delta H, then the sign will be negative. If we just give a sign with the reaction, that will be positive. Now we can take other examples of exothermic reaction. For example, this hydrogen plus chlorine gives twice hydrogen chloride. In this reaction, delta H will again be negative. It is minus 184.6 kilojoules. Let me give some other examples. Say carbon plus oxygen. Both carbon combines with oxygen to form carbon dioxide, and here again delta H will be negative, and it is minus 393.5 kilojoules. So in all the cases delta H is negative, but heat shown in the reaction, not delta H, that will always be positive. So these are some examples of exothermic reactions. Now coming to endothermic reactions. In endothermic reactions, quite reverse of exothermic reaction takes place. For example, let me go to the definition first. Endothermic reactions. Endo means absorption. Here heat is absorbed. So these are those thermochemical reactions where heat is absorbed, not evolved. So those chemical reactions in which heat is absorbed are called endothermic reactions. Now in endothermic reactions, what about the heat of products and heat of reactants? That is like this. Heat of products will be this time greater than the heat of reactants. That is, delta H will be HP, that is heat of products minus heat of reactants. This time delta H will be positive. While in endothermic reaction delta H was negative. But here since heat is absorbed in these reactions, so heat absorbed will be given negative sign. Heat absorbed will be given negative sign, but delta H will be given positive sign. So this is all about sign. Now coming to some examples of endothermic reactions. This is a typical example of endothermic. Nitrogen plus oxygen gives twice NO. Now see, in this reaction, how much heat has been absorbed? 180 kilojoules. That means this amount of heat has been absorbed in the system. Here what happens to the heat? In first case, heat was transferred. In exothermic, heat was transferred from the system to the surrounding. Here what happens? Here heat transfers from surroundings to the system. Reverse of first case, surroundings to the system. So in endothermic reaction, heat transfers from the surroundings to the system, and the sign given to heat absorbed is always negative. But as far as delta H is concerned, if we want to write this reaction in terms of delta H, we can rewrite this reaction like this. N2 plus O2 gives twice NO. Now we will write here delta H. Delta H will be positive. That means it is endothermic reactions. Endothermic reaction. So in terms of delta H, the delta H will be positive, 180 kilojoules of energy. We can give some other examples of these reactions, that is endothermic reaction. For example, this combination of hydrogen plus iodine, both gases, gas, combining to form hydrogen iodide. Here again delta H will be positive and it will be 53.5 kilojoules. What does this mean? This is positive. This means that this much amount of heat has been absorbed. It has been transferred from the surroundings to the system. Similarly, we can give another example of decomposition of HgO, mercurous oxide. If it undergoes decomposition, it forms mercury plus oxygen. And again delta H, it is 131.2 kilojoules. Again this positive sign means this much amount of heat has been absorbed. It has transferred from the surroundings to the system. That means it has come from the surroundings and it has been added. It has that is why it has delta H has positive sign. Let me take some I think these examples are sufficient. These all examples are endothermic reactions. Here I would like to put light on some other matter, that most of the chemical reaction, please remember that most of the chemical reactions take place at constant pressure. Most of the chemical reaction takes place at constant pressure. But if temperature is also kept constant, then these changes occur. That is delta H here gets positive sign, and whereas the heat content is negative sign in terms of in these endothermic reaction, while it was vice versa. It was quite opposite of it in the exothermic reactions. So that is all for today. That is thermochemical reactions. Thank you very much.